Hello everyone. So today we are going to talk about search algorithms. It is our first session of the course preparing to GCSE. And as I mentioned before, we are going to talk about search algorithms today. So we are going to cover the difference between linear search, binary search, what they are, how they work, and we are going to compare some of their features. So let's start with introduction to search algorithms, what they actually are and what they are used for. It is basically a way that allows us to find a specific element in a sequence, let's call it a collection or a list, array, etc. And it's crucial for efficient data retrieval in computer science and software, when we are working with databases, with some large information, etc. Why would it be important for us? First of all, it is used everywhere, from looking up on contacts, in case if we are talking about our phones, etc., or even up to large databases and databases queries. Now, let's focus on linear search. What linear search is? Its concept said that it is basically a straightforward way when we can iterate through each of the elements in our sequence. We are checking it one by one until we find the target that we were looking for. And the main key points that it can work for both sorted and unsorted list sequences, etc. We don't have to have our collection sorted to apply linear search. We are going to talk about importance of sorting collection just in a tiny bit when we switch back to binary search. And there is one more important thing here mentioned, time complexity, which is O of n, and it said that it is not efficient for large data sets. In course of A-level computer science, you're going to work deeper with time complexity. I will show you a few examples today. It will be quite simple to understand why it's exactly O from it. Now, let's have a look at some example of linear search. Let's assume we have the next list of numbers, 4, 2, 7, 1, 3. As we can see, this list is not sorted at all, and number 7 is 10 in the middle. And we want to find the position of number 7. So what would be our step-by-step solution? First, we would start the first element, which is 4 in our case. We would compare each element, starting from 4, 2, 7, etc., with our target, which is 7. Then in case if the current element matches the target, we would return the index of the position of the element that we are looking for. In case if not, we are moving to the next element, which would be 2. And then we are going to repeat all of these 3 steps over and over again until we find one. In case if it happens, the target is not found, we are returning -1. Yeah, why would we return -1, not 0? You're going to ask me. Because we know in case we return value of 0, it will state that the value, the index, would be 0, which is the first element in computer science. So we know it cannot be 0. We are returning -1. The next search algorithm that we are going to talk about is going to be binary search. So its concept said that it is more efficient method, but we must make sure that the list is sorted. And what does it do? It repeatedly divides the list into halves until it finds the target. And again, among the key points, it only going to work only with sorted list, nothing else. And when we talk about time complexity, it's going to be log n. Again, a bit later, I'm going to show you why it's going to be exactly log n. And we can assume that for now, that log n is going to be working faster than linear search for large data sets. Now, let's have a look at the next example. We have sorted list of numbers from 10 to 60. Again, important thing, it must be sorted. Our target is to find the value where the value is 40 staying, or if it's even staying in the list. So first thing that we would do, we would start with the entire list. Afterwards, we would find the middle element, which would be what? We do not have middle elements in this current case. So what we are going to do, we are going to take our list into two halves. We are splitting it right here. And this is going to be our left part, and this is going to be our right part. We know that we are looking for the value of 40, and the closest middle element to the left, we are usually taking left part, is going to be 30, I apologize. And now we are comparing what? 40 and 30. We know that 40 is larger than 30, then we are going to get rid of all this part. So we're going to have just 40, 50, and 60. Now, we are going to look for middle element again, which is going to be 50 in this case. So we are getting rid of everything at left. We are moving and focusing just on 40. So again, we have 5 steps in this current case. If we had more elements, we would be splitting it more times until we get to the 40. So we found 40 in the list. We can say target is found. So how can we explain it? How we can come up with common algorithms for our search explanation? So we start with entire sorted list. We find the middle element. After finding middle element, we need to figure out if we are moving to the left part or the right. First thing. Second thing, we need to make sure that we have decided correctly what side we are moving to. In case if we are having odd number of elements, it's quite obvious that we are going to move either to left or to the right. In case if we have even number of elements, then we need to be careful. We need to take a rightmost element of left part and compare it to our target. In case if our target is larger than the rightmost element of the left part, then we are going to move to the right. And we are repeating all of these steps until we find the element. In the end, we always have just one or two elements left. In case if target is not found, we are just returning negative. Now we are going to compare linear and binary search. So we are going to use table comparison the same way as we used during previous sessions. We are going to compare the next 4 features such as data requirement, time complexity, use case, and implementation. So for linear search, we have stated that it does not have to be sorted. It can be anything, either unsorted or sorted, but for binary search, it must be sorted. Time complexity, linear search, it says it's going to be ON. For binary search, it's going to be log n. For use case, linear search is really good in case you are working with not a big data, such as small data. Let's assume we are working with a list of students in a class. Binary search is better for large sorted data sets. And implementation of linear search would be quite simple. We're going to have a look at this during the second part of our session. For binary search, it's going to be slightly more complex. We're going to work on Flowchart, Pseudocode, and actual Python code implementation. Let's think at which case we would use either of them. When we would choose linear search or binary search. So linear search is perfect, as we mentioned before, for simple cases when data should not be sorted and the data set is short. And binary search is perfect when we are working with large data sets that must be sorted. Because in this case, we need to pay attention to efficiency. So in this part of the session, the first part, we've talked about definition of linear search or binary search. We compared them. We compared their efficiency, their complexity, what cases they're using, when they need to be sorted, when they don't have to be sorted. In the second part, we are going to draw flowcharts, write pseudocode, implement Python code for these 2 cases. But now we are going to move to second part. As announced before, we're going to work on Google Doc with a few exercises that I have prepared already. We're going to also go to Flowcharts and to write some Python code. The first exercise that we're going to work today is going to write in Pseudocode to find specific name in a list of students. I have prepared the template for us. So the first thing that we are going to enter and there are a few ways how we can do it. Let's write down Pythonic basic way. How would we write it down before? For, we would say, we could have started writing down for name in, like we would do it in Python, but again, it's not Python. So we are going to write down IDX starting from 0 to, we know in advance that it's going to be 5. So we are going to say then, 1, 2, 3, 4. If we are going to check if the value of, let's say, our list is called names. Names ith is equal to, we can write down equal to target we would create variable output where we would store the value equal to. Then we can check if the value exists. Yeah, let's even do it in a better way. Assume output is equal, we put the value of -1 in the beginning there. In case if it's not going to be equal to -1, how do we know it's not equal to -1? It means that we bumped into some value which is equal to target. If we bumped into such value, then the value will be overwritten, and then we can output, let's call it output value, or even better, target position. And we're going to print out our target position. Let's add extension now. So as you can see, we applied linear search algorithm to find the position of our target name that we would enter from keyboard. Again, I would like you to pay attention that we are moving here from 0 to number 5 not including, so you can write down 4 instead of 5. Now, what we are going to do, now we are going to switch to the platform that we have used before. So we would ask user to enter a name. We would store target from the user input. We would target index. Was it index? Now we are going to use the platform that we used before to draw flowcharts. So I have prepared what the first step would be entering a name. We would store our target in user input, and we would be looking for target what? Target position. Let's make it a bit larger. Target position. Then we would run what? Here we are not just going to check the position. Here we are going to make it a bit more complicated than just checking the position. Here we are going to say iterate. We are going to run repetitive. We are going to check the index. Index is less than 5. If the index is less than 5, So what we are going to do here, in case if index is less than 5, then we would be running a condition what our condition would ask us about. Let's change the example that we had before. Then we would say that our target position is going to be the value of index. Here we were supposed to say to compare target to our target. In case if this is known, then where are we moving? We are moving back to our loop. And in case if this condition is failed, in case if it's larger than 5, then what we are finally doing? Then we are finally able to move to our output total. And then from output total, we are already able, let's copy one more, move to the end. This is our final version of Flowchart. Now let's move to the second exercise, which is asking us to find number 34 in the given list of even numbers starting from 0 to 50. As we can see, this list is already sorted. So let's have a careful look at the initial setup. What I would recommend you to do in such cases, let's say we are having low value and high value. So low value would be the index number of the first element, which is 0. We know how many elements we have here? 26. Starting from 0, the first element, and first 25 even numbers. So then high value would be equal to what? 25, because it's the 25th index element. The next step, we can say it's going to be our first iteration. So what's going to happen during the first iteration? During the first iteration, we will be finally able to find the middle value. How would we calculate the middle value? It would be low plus high and integer division by 2. We remember, what is integer division? We are getting rid of decimal part. In this case, it's going to be equal to 12. Now, middle value is going to be equal 12th element going to be equal to 24. Element with index 12, not just 12th element. So this is index 12th index. Yeah, let's try to double check it. First, second, third, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Element number 13, but index is number 12. So what we can do with the list, let's copy this list. So we found element 24. And we remember our target is 34. So we are going to have a look at the left side and right side. But before we know what side we are going to, left or the right side, we need to compare our value 34 with 24. We know that this is 34 is going to be larger than 24. That's why we are going to move to the right side. Starting, now we are going to update the value of low and high. second iteration. So what low and high are equal to? Now, low is getting equal to 13, high still staying to 25 because we are still staying in the right part. Middle value, very calculated middle value. So in this case, we're going to have what? 13 and 25, which is 38 divided by 2, which is going to give us 19. And element with index 19 is going to be 38. Let's have a look. 38. 38 is staying here. So we are saying 34 is left side from 38. So what's happening now? We are setting up high value, resetting up the high value. So we are moving to the third iteration. Third iteration. Low value is still 13, but the high value is now 18. In this case, we know that this is going to be equal to what? To 15. So middle value is now going to be equal to 13. Let's have a look. Let's get rid of this part. Now we've got to 30. Now we can see that 30 is, again, we're comparing middle value to target value. 30 is less than 34. To all of these steps, let's add one extra step. 24 is less than 30. That's why we are taking right part. 38 is larger than 34. Taking left part. 30 is taking right part. Now, how many values do we have? Our iteration number 4. So low value is jumping up now to which value? To value 16. And as we are getting to the point, middle value is 34. Target value found. Target value. So let's see what we were doing here. We set up low value 0, high value 25. With each step, when we find middle value, a middle index, we are either updating low or high value. So in the first case, we updated high value to the next after middle one. Low still stayed the same. After we found the middle value, which is equal to 24, middle index was 12, we updated the low index to 13. The second case, after second iteration, we updated the value of high index to 18 to the next of middle one, previous middle one, which was 19, because we were moving to the left. And then in the end, we managed to find that our middle value was 34. Now, let's try to write down pseudocode. And now let's write down pseudocode for this case. What it would be looking like. Let's use the example that we used before. Let's keep the value, numbers, and target in front of us. So we would ask user to enter the target number, and let's call it target as well. Let's make sure that numbers is going to be sorted. Let's assume we have some function that is called sorted. Now, what we would need to do, we would need to set up values all low, which is again is equal to 0, and value of high, which we are going to say it's going to be length of our numbers minus 1. And we are going to do what we are going to do. We are going to move while low is less or equal than high. We are going to do the next thing. If numbers also need to define, we need to define middle value, which would be equal to what? High. Let's use low plus high. And we are not saying slash slash, we are saying division 2. And now we can say if numbers from mid equal to target, then we can what? Then let's say we are going to break the loop. We're going to break our loop. And let's call it stop. Stop loop. Then, if obviously we are ending if, and let's say now the next thing, in case if it's not equal, we need to check if our numbers if our mid value is larger than our target, then we are updating the value of high. How are we updating it? We are saying mid value -1, and we also have what? Else case. In opposite case, what we are doing? We are updating the value of low by increasing it by 1. Here we are ending our and if and saying and 1. In opposite case, let's assume we did not find any values. We would output -1. Let's go through this pseudocode again. In the beginning, we are making sure that our numbers are sorted. Afterwards, we are setting up the value for low equal to 0, and for high, number of the last index in our list. We are going to move until the moment our value of variable low is less or equal high value. Yeah? So the case when we are having only one value left. And we are making sure we are dividing correctly and finding the average of these two values. Afterwards, we are comparing the middle value to our target value. In case we found it, we're just writing out the message. Yeah, we found it. We are stop while. We can say stop while. Otherwise, if we know that our number in the middle is larger than our target, then we need to lower down our high value. In opposite case, we need to update and to grow our low value. Now let's try to draw our flowchart for this algorithm. So now we are going to insert the algorithm, enter target number. Then instead of target position, now we have low value. We have what? We also have high value. which is equal to len of numbers minus 1. Now our condition while low is less or equal high. In case if it's equal, we are going to check middle value. And we need to add one more important thing. We need to add calculation of middle value, which is going to be, as we mentioned before, low plus high. And there is one more element missing here. What element? This element. Instead of mid, we would have, instead of index, we would have mid here. Output negative 1. So this is one of the ways how we could present our flowchart. Let's copy it to our document. What we are going to do now? Now we are going to write implementation. Now we are going to write down implementation in Python for both of the searches. Let's use the example that we used to have before. Target, let's rename it a bit. So I'm going to use functions in this case. So let's say we have a linear search. Linear search, and we have some array and target value. Target value. So what would we do? We would use for index in range 0 to len of the array, and we would compare if our array index is equal to our target value, then we are going to return the index. In the case if we went through all of the values and we did not manage to find the value, we would just need to return negative. Now let's try to call our search, linear search from numbers and target. Let's say that our array would be equal to numbers and target value would be equal to target. Let's try to run it and see the output. We can see the output is equal to 70. Now let's improve our code a bit and let's turn it into binary search. So what changes we would need to do? Return negative 1 is still staying. We are saying low is equal to 0, high is equal to len of array minus 1. And we are saying while low is less or equal than high, we are going to check middle index. We are going to set it to equal low plus high. And here we are saying / equal to if our array at value, mid2 is equal to our target value, then we would just return array mid. And again, we would be checking if our array mid is larger than target value. We can actually even move it into one value. Let's check if target value is larger in this way. Then we would increase our low equal to mid plus 1, and else we would say high equal mid minus 1. In case if none of these worked out, then we are going to do what? Then we are going to return just negative. Let's call both of these together. binary search to make sure we both have got value 17. So we are starting our code here, and it was pretty much everything that we were going to cover today. I hope that you enjoyed this session today. We were talking about different searching algorithms such as linear search and binary search algorithm. We were writing pseudocode, we were writing Python code implementation, we were drawing different flowcharts. And next time, as I mentioned before, we are going to talk about sorting algorithm, and then we are going to implement and to see what is time complexity is. And again, next session, we are going to talk about sorting algorithm. We're going to speak about bubble sort and merge sort. We're going to use definition of time complexity again. So we are going to apply the concepts that we were talking about today, the next lessons as well. And for now, that's all. Thank you for